All right, good afternoon, everybody. My name is Charles Givre, and I am going to be giving a talk today about drilling security data. I want to thank, first off, the organizers of the conference for inviting me to come speak. And just a little bit about myself, I'm a lead data scientist at Deutsche Bank. I'm a project manager, PMC member for the Drill project, and I also have my own cyber training company, GTK Cyber. Before that, I worked for a long time at Booz Allen, and I worked at CIA. I wrote a book on Apache Drill, if anyone's interested in that after my talk today. And yeah, those are some of the places that I've worked. I play trombone and fix up old British sports cars. Okay, so, all right, can I just see a show of hands? Who here works in security, in a security capacity in some way? Interesting. Okay, cool. All right, so you could probably relate to the statement that's up on the screen. That is that analyzing security data is challenging. It's hard. It's really hard. And why is that? So part of the reason why I think that security is a really fun problem to work on and challenging problem is the nature of the data itself. The first issue is that security data comes in many, many different forms. If you think about any serious security program, you're going to have to look at things like spreadsheets, JSON, XML. You're going to be looking at log files, PCAP, all sorts of binary stuff. There are all kinds of different data that you're going to have to kind of make sense of. Now, what's more than that is your data is going to be living in different places. It could be in a file system, distributed or otherwise. It could be in cloud storage. It could be in databases. It could be streaming data. There are all different types of, not only types of data, but locations for this data. And bringing all this data together in a way that makes sense and can be analyzed is very, very difficult. I mean, would everybody agree with that? Okay. So what I've kind of come to the conclusion is that there are very, very few tools that can analyze these data types really effectively, but even worse is that there are even fewer tools that can analyze all of these different types of data effectively. Now, where I work, I mean, we use kind of like, the standard parties, Splunk and Elk, and probably everybody here has probably used some, these two if you're in security. But they have some pretty, they're good for certain things and not so great at other things. For example, and then Wireshark, it would be a good example of something that's good for PCAP analysis. But what this really comes down to is that security data is not arranged in a way that is good for ad hoc data analysis. Meaning that if you have different types of data, you want to join them together, you want to play with them, do machine learning with them, it's very, very difficult to actually do that. And on top of that, I haven't even said anything about the scale of our data. If you're protecting an enterprise, you could be looking at terabytes of data a day, and it's a very serious challenge. So what people tend to do is they tend to implement some sort of architecture that looks like this, where you have your data and your various sources, you put it through some sort of ETL or extract, transform, load process, and you put it into some sort of analytic store or a data warehouse where you can do that. And this works really well, right? Okay, yeah, so you see where I'm going with this. The ETL process is, in my view, expensive and wasteful. I can personally attest that companies I have worked with spend literally millions of dollars on ETL. And if you think about it, it adds no value to the end product. The end product being risk reduction, analysis, and so forth. So study after study shows that this is just a huge problem in the industry. Analytic teams can spend between 50 and 90% of their time doing this. And I saw this, and I thought I have to get this into a presentation. It was that 76% of data scientists say that doing this kind of data cleaning in ETL is the least favorite part of their job. So, sorry? Yeah. And what this comes back down to is this whole ETL process consumes the most time and adds no value to the product. Now, I started thinking about this in, if you're familiar with Six Sigma, it's a manufacturing, way of thinking. Lean Six Sigma, it's a philosophy that kind of came out of manufacturing, and they identify the idea is to minimize waste. And there are 8 wastes that exist. I'm not a Six Sigma expert, as you can probably tell already, but among them are transportation, motion, and extra processing. These are three big wastes that exist in basically everyone's analytic process today because of this whole ETL process. So, where does drill fit in? Well, let me ask this. Who here has heard of drill before today? Wow, okay. Who's used it? Awesome. Okay. I'm going to ask again who wants to use it after I'm done with my talk today. So I'm curious to see if I've convinced anyone to try it out. All right, so what is drill? Well, the official definition of drill describes drill as an SQL engine for self-describing data. So what does that mean in practical terms? Well, the way I see it is drill lets you query just about anything, just about wherever it is, pretty much no matter how big it is, using standard SQL. Almost anything. And if you're a Star Trek fan, I like to kind of think of this as a universal translator for data, whereby it makes it such that any data can speak SQL. So from an architectural standpoint, what this enables you to do is you can get rid of that, you can get rid of that, and you can replace that with drill. Now, drill, because it kind of speaks SQL, and it acts like a database, even though it isn't strictly one. It has ODBC and JDBC and other interfaces, so that if you have tools that are used to working with databases, you can connect them to drill. And from the end user's perspective, they think they're talking to a database or working with a database, but they could be working with a Hadoop cluster or MongoDB or whatever. And so it's a really kind of interesting paradigm. And I made up this silly cartoon here, but it really kind of illustrates the point where you have an analyst who puts in an SQL query and gets a table back, and it's like, whoa, I can query PCAP as if it was SQL. But you'll see, this is kind of really how it works. So, okay. So what I'm going to do now is I want to walk through a few, actually, let me back up a step. I was at drill has existed, I think the first stable version was released in 2015. It was inspired by the Google Dremel paper, which if you're interested in it, it's really interesting. It talks about how, columnar data stores and so forth. Anyway, I'm not going to get into that. But I got interested in drill. I was working on a project using Spark, and we were having some difficulties with it. And so I happened to mention that to somebody at the Strata conference in Silicon Valley, and they asked me, "Have you tried drill?" And they explained what it was. And at the time, we were trying to read large amounts of CSV files into memory and do some things with it. So I said no, and they explained that drill could enable you to query these files using SQL. So I tried it, and it was terrible. I saw this person at another conference a few months later, and I mentioned that to them, and we started talking about it further, and then kind of an offhand remark, they said, I've always wanted to get drill to be able to query PCAP files. And it was just like a light bulb went off in my head, because it was like, oh my gosh, if drill could query PCAP files, it could query basically any kind of log files, and then you could join all these different things together, and then it just kind of cascaded. And so my kind of quote-unquote mission for the last few years has been to really enable drill to have these security-related functions so that you can use it for security analysis. So with that said, I'm going to walk you through a couple of kind of simple use cases just to illustrate how drill can be used for security analysis. Now, none of these are too crazy sophisticated, but I just want to show you kind of how this could work. Hopefully spark some ideas. There's a lot more functionality that I'm not highlighting, and if you're curious, I'm happy to talk to you about it. In this demonstration, all of the screenshots are using another open source Apache product called Superset, which is a really, really slick open source BI tool. It's not officially an Apache project, it's incubating, but there are instructions on my blog about how to connect drill and Superset. So if you're interested in like what you see, that's how you can learn how to do it. So okay, the first example I'm going to show you is our web server logs. Now, this is what a web server log, lines from web server logs look like, and you can see they're pretty ugly. And I mean, there are a lot of tools that can rip this apart, but if you can't really break these apart by tabs or by spaces because some of the fields are delimited, some of them aren't, some of them are enclosed by quotes. Real headache. Okay, so drill can read these natively as of like version 1.9, I think. And you can, so if you were to just do a select star in this, you would get this list of fields. And so this is not complete, that it was actually too long to fit on the screen. But what you can see here is the drill can interpret all these fields, assign the appropriate data types to them, and so forth. And again, so if you were to do a select star on a log file, what you would get is what you see here. And again, this actually goes, this would probably go all the way out the room, down to the washroom or something if I had the space to do it. But there's a lot of data here that you can work with. So this particular sample file was posted on someone's GitHub repo, and it was just kind of showing you like someone trying to hack into this guy's site. So there is a URL called join form that's not public. So what we're going to do now is I'm just going to show you a few different features to demonstrate how you can use drill to explore this data. So first thing we might want to do is just a simple select query where we're just kind of picking out a couple of columns just to see what's there. And we're going to filter it using this join form right there so we can see who's actually trying to access the site. So if we do that, you can see we get the date times, the IP addresses, and the user agent strings. Any questions so far? We good? Hands up if you're still awake. Okay, just checking. All right. Now, Superset, in addition to being able to query data, enables you to visualize it very quickly and easily. So if you just notice right here, there's this nice little button right here called Explore. If you click on that and just play with some of the settings, I didn't put all this in the slideshow, but you can generate this, which is showing you the number of hits per hour on this particular URL. So, okay, but let's take a look at these IP addresses. Now, one thing, if you have IP addresses, there's a lot of kind of I don't know what you want to call it, metadata, other artifacts that you can pull out of an IP address if you know how to do that. Now, one of the things that really attracted me to Drill is that it has a very flexible interface for writing your own custom functions. And there are an ever-growing collection of functions that people have written for Drill to do various analytic stuff with it. There's a whole suite of GIS functions, for instance. Yeah, anyway, so one of the projects I worked on was a whole collection of GeoIP functions which enable you to geolocate IP addresses and do all sorts of fun stuff there. And so here's the complete list, conveniently written in 2-point font for you guys in the back. So the key ones that I want to highlight are the get country name and get city name, and also the get latitude and get longitude. So if we add these two fields that are highlighted in red there, what you'll notice now is the query now is able to resolve the country name and city names for all these IP addresses. We can then hit the explore button again and generate some graphs so we can see at what time of day people are trying to attack this particular site and where they're coming from. Or we can add the latitude and longitude there, as you see there, and then we can map it. Again, this is all using the capabilities of Superset and Drill together. Now, another kind of neat thing that we can do is we can take a look at those user agent strings. Now, it seems like most of the people in this room are familiar, do work in security. If you're not, user agent string, it's something that's passed when you when you submit an HTTP request or you request a website. It basically it identifies the equipment that the request store is using. So it would have stuff about the browser, the OS, etc. It's very useful. It's useful for legitimate uses and also just seeing who's accessing a website. Now, one of the big differences between Drill and a conventional database is that Drill allows multi-dimensional data structures, including maps and lists. So there is, and in addition to that, there is also a custom function that was written by a Dutch gentleman that will enable you to parse user agent strings and break out all that information into a map. So if you were to execute this query, and we have the parse user agent function up there with the user agent field, you can see now it's extracting all of this data about the user agent string. So from there, we can pull out the individual components in this query right here. And you can see here now we have all the OSs and the browser, and you can group, aggregate, count, do all that kind of fun stuff, or you can create you can visualize it again, same way that we did earlier. Is this cool? All right. Okay. Any questions so far? Yeah, sir. If you can use drill, why do you need Splunk and Elk? That's a good question. Because you like spending more money than you have to. No, in all seriousness, I think drill is probably like maybe 80 to 90% the way there in terms of raw analytic capability of being able to do that. There are still some things I think that Splunk or Elk can probably do that drill can't, but as more and more people adopt drill, I think that gap is going to be rapidly closed. Sir?
I think Splunk is used for the messaging part also, be able to do the data aggregation.
Yeah, that's actually a good point. So drill doesn't have a native UI, and that was one of the things that really attracted me to the Superset project, is that by combining drill's analytic capability with Superset's visualization, it really has enormous analytic power. Do you have a question, sir?
Are you going to go into any of the architecture and how it scales versus other things?
I didn't plan on talking that, but I'm happy to talk to you after about that. Okay. So the next kind of category of stuff that drill can analyze that I wanted to demonstrate were PCAP files. If you're not familiar, PCAP stands short for packet capture, and it represents raw network traffic that's captured over the wire. These files are binary files, so you can't just open them in a text editor and look at them. You have to have something that can parse them. And so drill, I don't remember the version it was introduced. It has the capability of reading PCAP files natively. It also, I don't remember, again, I apologize, it was a fairly recent addition that you can also read PCAP NG files. So if you were to do a select star on a PCAP file, you get the list of fields that you see behind me. And yeah, so now, I was going to say one thing about this. So this is actually something I think that drill, it's definitely a work in progress. There've been, in the last few releases of drill, there've been a lot of improvements to these particular features, and the next version of drill, which is scheduled to be released probably mid-April, has a number of very significant improvements to the PCAP parser. So if you want to use this, you might want to either use a release candidate or just wait a few weeks to really try this out, because there's going to be some really good stuff in there. Now, drill has built into it a collection of network analysis functions whereby you pass it an IP address and it kind of does something. So I'm not talking about GeoIP. This would be like, there are functions to determine whether or not IP addresses are valid or private or insider blocks or things like that. So there's a bunch of that stuff, and it's available in the documentation. You can check that out. So like, again, if you were to select star on a PCAP file, this is what you get. You can see, the type, the network, the timestamps, the IP addresses, MAC addresses, and all that kind of stuff. So just a simple kind of thing you might want to do is look at who's talking to whom. So what computers are communicating with each other. So you could do a select distinct on the source and destination IPs. That would get you unique pairs. And then Superset has a pretty nice visualization of that. So this chord diagram, you can very nicely see who's communicating to who. And this was not a very large PCAP, so it doesn't really look that interesting. But there's also visualizations for directed graphs and then Sankey diagrams, so you can really kind of get a sense of that flow. One of the kind of interesting use cases I was thinking of was Synflood Detection. So this is a form of a distributed denial of service attack or DDoS attack, whereby in the TCP handshake, an attacker would first, so a normal TCP handshake, the person requesting it will send a SYN packet. They will then receive a SYN ACK packet, and then the sender will send an ACK packet, and then the connection is established. With a Synflood, hold on, did it not show up? Oh. Wrong button. Okay. With a Synflood, what happens is, damn it. Okay, there we go. Instead of that final acknowledgement packet, the attacker would send a SYN packet and do this over and over again. So you have all these open connections, and if this is done in enough volume, you can have a denial of service attack. So You can actually automate this, detecting this with a custom user-defined function. This I thought was kind of a cool use of SQL and PCAP files. So there's a Synflood function, which returns true or false if that particular condition is present, and if you apply that, you can get session IDs of where that's happening, and then you can then look up all the data from those sessions and see what's going on in them. Any question? Yes, sir.
Synflood the analysis is reactive.
Yeah, that would be reactive. I mean, you could theoretically do it. So drill's really meant for, like, it's ad hoc analysis, but you could do something like you could have some sort of cron job that would be querying this periodic, at regular intervals, and kind of detect it like that. Sir.
Does drill store any information that it gathers while it's executing a query, or does it always pull the information from its original source?
So this is something that's kind of evolving. Initially, it really didn't. However, that obviously has a lot of performance implications. So there's where it's going right now is drill it's kind of in the process of implementing some meta stores and some other ways of caching various aspects of the query so that so that we can gain performance improvements that way. One of the things it does now is it has some code that's basically done. It's a just-in-time compilation. So the first time you execute a query will always be slower than subsequent times when you are querying a specific data source. But yeah, anyway, the answer to your question is yes, soon. Okay, so log files. Now, in the interest of time, I'm just going to say this. So Drill, as of the version that's coming out in 2 weeks, Drill can query Syslog formatted files natively. Version 1, so that'll be version 1.16. It can also, there's a generic log parser, there's a generic log reader as well, so that has existed for some time now. So this requires configuration, so this would be you have to write a regex and define fields and so forth, and then once you've done that, it can query a log file. So if you have a log file that looks like this, once you've kind of defined those settings, you could execute queries and then do a lot of the same tricks that we've seen earlier. You can, it will extract all the fields for you. It can put them in the right format, and do all that wonderful stuff. And yeah, so it can query syslog formatted data as of version 1.16. So with that, I have 5 minutes left. Are there any questions, sir?
I believe SQL means that you can query the entire data and process streams of data.
Okay, so the question is, can you process streams of data? Sort of. I have not done this personally. Drill recently introduced a storage plugin for Kafka, and so you can query, if your data is being streamed via Kafka, you can query it that way. Yeah. Like I said, I've not really used that. I haven't really played with that yet. So, but I know that you can do it. Sir.
I'm having a little trouble grasping one of the concepts of how does it actually access the data, the raw data? I mean, is there an agent running on each system, saying, hey, give me this Syslog. You have to have something running Wireshark saying, hey, give me the traffic, and where does it put this information?
Okay.
If you install an agent, that's basically installing a security violation.
Right. So Drill can, so it can read from a number of different.
Or vulnerability.
Yeah. It can read from a number of different. The Drill term is storage plugins. So if you have data that's stored on a file system, you don't have to install anything on that file system for Drill to be able to read it. You just it has to have access to it, and but there's no agent you have to install on it to be able to read it to read from that. So what I would the architecture that I would recommend is pointing Syslog to like a large data cluster and then giving drill access to that cluster. So that's kind of how I would. You're not reading it from the endpoint. You're reading it from where like the remote the logging would be sending the files, if that makes sense. Yeah. Anything else? I'll put in a shameless plug for my book. Which, my co-author Paul Rogers and I, who's also a PMC member, we recently released the O'Reilly book about a drill, and that's it. So thank you very much. Oh, Paul Rogers. Thank you very much. And I'm just kind of curious. Have I convinced anybody to try out drill? Awesome. Mission accomplished. Thank you very much.
Nicely done.